In this video, we are going to talk about integration by substitution. So we will understand this concept by solving a problem. We have a function that we have to integrate, which is x square plus 1 whole power 50 into 2x, and we have to integrate it with respect to x. Now there isn't any known formula that we can use directly to solve this integration problem. Here we are going to do some substitution. Whenever you have to substitute, so you have to look for an expression such that the derivative of that expression is also here. Now we can see that there is this term x square and its derivative is 2x, which is here. But try to pick as big an expression as is possible. We know that derivative of x square is 2x, but we also know that if we pick an expression x square plus 1, then its derivative is x square derivative is 2x plus, and derivative of 1 is 0. So x square plus 1 derivative is also 2x. So the general rule to pick an expression such that its derivative is also there is that if you see inside the integral sign a complex expression, pick a tiny part of this complex expression, put this thing equal to t, but that tiny part should have its derivative also inside this integral. For example, here the complex expression here is x square plus 1 to whole power 50. But I'm not picking this whole part. I'm just picking this complex expression's tiny part, which is x square plus 1, such that its derivative, x square plus 1 derivative is 2x, is also here. So we pick x square plus 1 because its derivative 2x is also here, and we put this equal to another variable t. Now we will find the differential. Differential of an expression is just like finding the derivative. For example, when you find the derivative of x square with respect to x, so you just say 2x. But when you have, let's say, x and you are asked to find its differential is dx. When you have an expression x square and you are asked to find its differential, first you find the derivative, which is 2x, and then inside you have x, its differential, which is dx. Let's say you have sine x, you have to find its differential. Sine x derivative is cos x, then angle here is x, its differential is dx. This is how you find the differential. Now let's say you have x square plus y square and you are asked to find the differential. X square differential would be first its derivative, which is 2x, and then x differential is dx, plus y square differential is first its derivative, which is 2y by power rule, and then y differential, which is dy. Let's say you have sine x plus x square plus t square minus y, and you have to find the differential of this expression. Sin x derivative is cos x, and then x differential, which is dx, plus x square derivative by power rule is 2x, then inside you have the variable x, its differential is dx, plus first the derivative of t square by power rule, it is 2t, and then t differential is dt, minus derivative of y is 1, but then the differential of y is dy. So that's how you find the differential. Let's get back to our question. Now we suppose x square plus 1 equal to t, and then we find the differential. X square differential is 2x and x differential is dx, plus differential of 1 is just like the derivative of 1, which is 0 because 1 is a constant. So differential of 1 is 0. Differential of t is dt. We'll simplify it. 2x dx equal to dt. From here we will find the value of dx, which is dt by 2x. Now put this x square plus 1 equal to t and the value of dx in our integral here. Let's see what happens. X square plus 1 is equal to t to power 50, 2x as it is, and the value of dx is dt by 2x. Simplify. 2x cancels out with this 2x and you have t to power 50 into dt. If you get the entire expression here in terms of the variable t, it means that this substitution that you made in the beginning is correct. So now that you have t power 50 dt, what you can do is you can simply apply the power rule of integration. It gives you t power 51 over 51 plus some constant. But remember that this t was not originally the part of your question. We introduced t here. X square plus 1 was equal to t, so we will put the value of t, which was x square plus 1 to power 51 divided by 51 plus some constant. So see, in the beginning we were not able to solve this question by any known formula of integration. So what we did is we made the substitution. And how did we pick the substitution? That we looked to find some term such that its derivative is also here. So usually from a complex part, we pick a tiny part and put it equal to a different variable, but that tiny part has to have its derivative somewhere written here. So we picked x square plus 1, put it equal to t, and its derivative was 2x, which was also here. And then after making this substitution, we saw that the whole integral was converted into the variable t, and this integral was easier to solve by recalling the power rule of integration formula. Let's attempt another question by substitution. We have to solve this integral sine x plus 9 dx. Now there isn't any known formula that can help us to solve this integral, but what we know is integral sine x dx equal to minus cos x. But in this case, our angle of the trigonometric function is just x, but in our particular case the angle is x plus 9. So what are we going to do is we are going to put x plus 9 equal to another variable. But before we make this substitution, we have to think that if x plus 9 derivative is also here, x plus 9 derivative is 1, because x derivative is 1 and 9 derivative is 0. So x plus 9 derivative is 1 and here 1 is written. So yes, we can make this substitution. So x plus 9 is equal to t. Now find the differential. X differential is dx. Differential of a constant is 0. T differential is dt. So we have dx is equal to dt. Now put this x plus 9 equal to t and dx is equal to dt in our main integral formula. When we do that, we have sine x plus 9 is equal to t and dx is equal to dt. So our integral is entirely in the variable t, and we know that by this formula that sine t integral with respect to t is minus cos t. But since t was not originally the part of our problem, so we'll go up and see the value of t, which is x plus 9. So we will put here and some constant. So in these kind of questions, we just have to look at the main formula. Here the main formula was sin x dx was equal to minus cos x. But in the given question, the angle was not just x, it was x plus 9. So we thought that we will substitute it equal to another variable. By doing so, now our angle was just a plain variable, which was t. And then we use this main formula. Let's attempt another question by substitution. We have to find the integral of x minus 8 to power 23 dx. Now there isn't any main formula that we can use to solve this integral directly. So we will make the substitution. Now this whole part x minus 8 to power 23 is complex. So what we are going to do from this complex part, we are picking its tiny part, let's say x minus 8, and we are going to substitute equal to a different variable. But before that, we have to see that x minus 8 derivative must be here. The derivative of x minus 8 is 1, because derivative of x is 1 and derivative of 8, which is a constant, is 0. So we are going to put x minus 8 equal to t, its differential dx minus 0 is dt. Dx is equal to dt. Let's put x minus 8 and dx is equal to dt back in our problem. So we have t to power 23 and dx is equal to dt. Now we can solve this integral by power rule of integration, which is t power 24 by 24 plus some constant. But t was not originally the part of our question, so we will put the value of t, which is x minus 8 from here, to power 24 by 24 plus some constant. Let's solve another problem. We have to integrate dx by 1 over 3x minus 8 to whole power 5. There isn't any known formula that can help us to solve this integral directly, so we will have to do substitution. What is the rule to pick the substitution? That from a complex part, we pick a tiny part such that the derivative of tiny part is also there. Now here there is only one part which seems complex because it has the power 5. 1 by 3 x minus 8 to power 5. So we are going to pick this part 1 over 3 x minus 8, and we are going to put this equal to some another variable. But before that we have to see that the derivative of this term is also written here inside the integral. But we can see that the derivative of this term is 1 over 3, x derivative is 1, minus 8 derivative is 0, so it is 1 over 3. But 1 over 3 is not written here separately. But remember that 1 over 3 is a constant, and this constant would be adjusted later on. Suppose you have this expression and you are going to suppose x square equal to a different variable. But this x square has the derivative 2x. 2 is a constant, it is not important, but x should have been written here, like here. So only in that case you will make this substitution. So again we are going to pick 1 over 3 x minus 8 equal to t, because the derivative of 1 over 3 x minus 8 is 1 over 3, and 1 over 3 is a constant, it will be adjusted later. And now we find the differential 1 over 3 dx minus 8 differential is 0, because differential of a constant is same as derivative of a constant, which is 0, is equal to differential of t, which is dt. From here we find the value of dx, which is 3 dt. Now we put here the value of dx and 1 over 3x minus 8 equal to t back in our integral. Dx is 3 dt divided by 1 over 3x minus 8 is equal to t whole power 5. We will take this 3 outside, and t power 5 we will bring it up. It becomes t power minus 5. And see, our whole integral is converted into the variable t form. So it is important to know that if your substitution is correct, you will have finally the expression entirely in just one variable. If after the substitution your expression involves both x and t, it means there is something wrong with your substitution. So let's integrate this integral t power minus 5. By power rule of integration, it is minus 5 plus 1 divided by minus 5 plus 1. We can simplify this. 3 t power minus 4 divided by minus 4, which is minus 3 by 4, and this t power minus 4 comes down, becomes t power 4 plus some constant. But t was originally not in your question, so we will put the value of t, which is 1 over 3x minus 8 whole power 4 plus some constant. In the next video, you will see some more questions attempted using integration by substitution method.